Hello, welcome to the next tutorial on electric current. In this tutorial, I am going to explain the solutions, the questions I discussed in the last tutorial. Now, let me explain the solutions one at a time. Flow of charge is called electric current. Flow of charge is electric current. What actually travels through a wire when we switch on the light? It is electrons. It is always electrons which travel through a wire. Okay, I forgot the first question. Coulomb per second is called ampere. Let me explain. We know the formula I, that is flow of current, equal to Q by T, where Q is the electric charge and T is the time in second. I is ampere, Q is in coulomb and T is in second. So coulomb per second should be always called as an ampere. So ampere can also be called as coulomb per second, and coulomb per second can also be called as ampere. They are interchangeable. Next question. What constitutes electric current in a metal wire? It is always electrons, because in metal wire always electrons flow and that will constitute the current. So electron flow is responsible for current in an electric wire. Next question. What constitutes electric current in an electrolyte? It is ions. Because in electrolyte it is not the electrons, it is the ions which flow in an electrolyte, and because of the flow of ions, electrolytes can conduct electricity. Let us take an example of sodium chloride solution, which in water it dissociates into sodium ion, which is a positive ion, and chloride ion, which is a negative ion. And these ions are responsible for carrying electricity. Now, next question. In which direction does conventional current flow in an electric circuit? Conventionally, current flows from positive to negative, even though actually it moves from negative to positive. So conventionally it is positive to negative electrode or positive to negative terminals, whatever way it is. Which of the two shows the correct relationship between electrical units? Number 1, 1 ampere equal to 1 coulomb per second, or 1 coulomb equal to 1 ampere per second. Let us see again. We know the formula I equal to Q upon T. So I is in ampere, Q is in coulomb and T is in second. So coulomb per second is actually 1 ampere. 1 coulomb per second is 1 ampere. So first one is correct. 1 ampere equal to 1 coulomb per second. What is the unit of electric current? It is ampere, or you can also call it as coulomb per second, but SI unit of electric current is ampere, and 1 ampere equal to 1 coulomb per second. Next question. In 1 ampere, how many milliamperes and how many microamperes are there? Now 1 ampere equal to 10 to the power 3 milliampere, and 1 ampere equal to 10 to the power 6 microampere. Okay, next question, fill in the blanks. Ammeter is connected in, ammeter is used for measuring electric current, so it is always connected in series. And voltmeter is used for measuring potential difference, and it is always connected in parallel. Next question is explained in the diagram. Let me open the diagram. The first one. The first diagram represents a variable resistance. A variable resistance is also called a rheostat. The next one is a switch, electrical switch. Actually, it is a closed switch. If it for open switch, that in the middle that the dot will not be there. It is a closed switch. This represents a battery. A battery is a collection of cells in series. Is a connection of cells in a series. So this is a battery which consists of 3 cells. Okay, next one is a very small simple numerical problem. If 20 coulomb of charge pass a point in a circuit in 1 second, what amount of current is flowing? So remember, the charge, that is Q, is equal to 20 coulomb and time is 1 second. So we know the formula, I equal to Q upon T. I is the current flow, Q is the charge, and T is the time in second. So charge is 20 coulomb and time is 1 second. So current flow will be 20 ampere. Actually, it should be not C, it should be Q. Is a coulomb per second. Remaining problems I will discuss. Solution for the remaining problems I will be discussing in the next video. See you then.